Okay, in this video, we're going to begin with exercises from Chapter 5, Section 1. The first thing that we want to do is to tell whether an ordered pair is a solution of a system of linear equations. And we can do this simply by substituting, and I'll do the first equation in blue. We're going to substitute the value and for 3 for x and 1 for y. So since 3 plus 1, does that equal 4? We know that it does. Then with the second equation in green, 2 times 3, then minus 1. Does that equal 3? No, it does not. So is that ordered pair the solution to the system of linear equations? In order to be, that ordered pair has to be a solution of both equations, of each equation, not just one of them. And so the answer to the first one is no. Second equation, second system of equations. X is 1, y is 3. Does that equal negative 2? Yes, it does. Second equation in that system, 2 times 1 plus 3. Does that equal 5? Well, 2 times 1 is 2, plus 3, that does, and so we say yes. In the next system of equations, it says y, which is 0, is equal to 2 minus 2. Is that true? Yes, it is. The next equation, 0 is equal to negative 3 times 2 plus 6. Negative 3 times 2 is negative 6 plus 6. That is true also. Next system of equations. X is equal to negative 1 minus 2 times y is negative 2. Does that equal 3? Well, we get negative 1 plus 4, and that in fact does equal 3. Go back to two different colors again. Then we have 2 times negative 1 minus negative 2, and does that equal 0? 2 times negative 1 is negative 2 plus 2, and that does equal 0. So that one checks. So I didn't write on this third one that that one works, and the fourth one works as well. For the fifth system of equations, 3 times negative 2 minus 2 times 3, does that equal negative 12? We get negative 6 minus 6, and that is indeed equal to negative 12. Next, 2 times negative 2, which is negative 4, plus 4 times 3, which is 12, and does that equal 9? So let's see, we have negative 4 plus 12, and that is 8 and not 9, so we would have to say no for number 5. Number 6, 2 times 4 plus 2 times negative 3, does that equal 2? Well, we would have 8 minus 6 indeed does equal 2. Then 3 times 4 minus 3 times negative 3, does that equal 21? 3 times 4 is 12. Negative 3 times negative 3 is positive 9, and that equals 21. So we would say yes to that one. All right, we're going to go on to the next set of problems here. With the next set of problems, we're given 3 graphs. We want to use the graph to solve the system of linear equations and then check our solutions. Well, it appears that the first graph has a solution of x is 2, y is negative 2. And to check our solution, we should plug in x is 2, y is negative 2, and see if we indeed get 10. That's 6. Negative 2 times negative 2 is positive 4, and so we do get 10 there. In the second equation, x plus y, that would be 2 plus negative 2. Does that equal 0? And 2 plus negative 2 does equal 0, and so it checks. The second system of equations, it It appears that our solution is at x is -1, y is -3. All right, so then we need to test this out. And the first equation, x -1 minus 2 times -3, and does that equal 5? We get -1, -2 times -3 is +6, -1 plus 6 is 5, and that checks. Second equation, 2 times -1 plus -3, does that equal -5? We get -2 minus 3, and that does equal -5, so that one checks as well. Third system of equations. The solution appears to be at x equals 4, y equals 2. We're going to test our solutions. 4 plus 2 times 2, does that equal 8? 2 times 2 is 4, so 4 plus 4 is 8. 3 times 4, that would be 12, minus 2 times 2, 12 minus 4 is 8, and that one works as well. So we could see what the solution was graphically, and we just verified it by plugging in those coordinates into both equations and seeing if we get two true statements. All right, in the next set of problems, we want to graph the equation. We want to solve the system of linear equations by graphing. And so we start with y is 3 with a slope of -1. So this is how we graph an equation in slope-intercept form. We start with the y-intercept, then we use the slope to find additional points. All right, so there is our line there. Then we have y equals x plus 5. So in that equation, 5 would be up here, and it has a +1 slope. And so we can see from this that the point of intersection, or the solution of the linear system of linear equations, appears to be at x is -1 and y is 4. In the next system of linear equations, we start with, again, we can draw lines through these, no problem. The main thing is that we were able to find our solution graphically. In the next set, we have y is 1/2 x plus 2, so we start at 2, we go up 1 over 2, up 1 right 2, down 1 left 2, down 1 left 2, and so we have the purple line there. In the second set of equations, we have a y-intercept of 4 and a slope of -1/2, and so we go down 1 right 2, down 1 right 2, or up 1 left 2, and so we can see our second line, and we can see that the point of intersection is at x is 2 and y is 3. In the third system, remember that y equals -3 is a horizontal line. It's a line where all of the y coordinates are -3. So you could do 0, -3, you could do -2, -3, you could do 2, -3, and you can see the line that's created there. In the third exam, in the next equation, however, we can either solve for y, or we can find the intercepts, because this is in standard form. And so if I set x equals 0, I'm going to get the equation -2y equals 6, or y equals -3. So let's plot that. y is equal to -3, and there it is right there. And if I set y equal to 0, I am going to get 3x is equal to 6, or x is equal to 2. And plotting that, x is equal to 2. So I went up 3, right 2, up 3, right 2, and this is my second line. And you can see that the point of intersection is x equals 0, y equals -3. And so that does it for these problems. We have 2 more to go, so I will scroll down. In number 13, we have a y-intercept of 0 and a slope of 4. So the first line might look something like that. In the second equation, we have a y-intercept of 8 and a slope of -4, and so you can see where they will cross, and we're going to get two equations intersecting at the point x is 2 and y is 4. In the final system of equations, we have a y-intercept of 3, a slope of up 1, right 4, down 1, left 4, my bad, and that would look something like that. Then we have 5 and 3/4. So we're going to go down, sorry, that wasn't a 5, and we want to go up 3, right 4, but we can't do that, so instead we're going to go down 3, left 4, and we can see that our point of intersection would be right there at x is -4 and y is 2. And that does it for all of the problems in section and chapter 5 section 1. So we'll stop this video here.